All right, today in this video, we're going to be looking at inferences about two means. We're talking about with large and independent samples. So this is going to be a z-test, not a t-test. We are going to be knowing the standard deviations of the samples in this case. And of course, inferences implies we're doing hypothesis testing. So hypothesis testing with two means. So like, for example, here you got two cars going at different speeds. Is their braking distance actually different? Okay, that would be an example of doing an inference or a hypothesis test with two means. They would have their average stopping distance there. This is going to be, though, independent. You got to be careful here. This is independent samples. So I just want to go through what the differences are. Again, we've done this before, but just reinforce it. Independent on the left here are some examples of independent. If you had men versus women, because they can't be the same people. Placebo versus control, they can't be the same people. Ford and Chevy, all this, that you can't be the other thing. You can't have T drivers at the same time being elderly drivers. On the right side, we have things that can be the same at the same time, or at least the same person, maybe is maybe a better way to think of this. 60 days without medication and then 60 days with medication, being the same person. Before and after results for something, maybe like a weight loss program, would that be the same person? Midterm exam scores for 20 chemistry students, and then the final exam scores for the same 20 chemistry students. So on the right hand, everything is the same group. Over here, they're not the same group. Okay, so that's what we're talking about today. Independent, they got to be independent. Here's three more. Why don't you quick give them a try, see if you can make sure which ones are and which ones are not independent. All right, that first group, that is going to be dependent because it's the same group of students. The second one, those are going to be independent. Those are different engines, that's different cars. And of course, in the last one, we got male and female, which of course can't be the same animal, so that's going to have to also be independent. Okay, in this section here, just like most everything we've done before, the null is going to contain the equality. So equals, less than or equal to, greater than or equal to, and the alternative will not contain the equality. There are requirements to do one of these two sample z-tests when we're testing the difference between means. They must be randomly selected. The samples have to be, there's that key right there, independent. And they should be at least 30 in the sample size. If not, each population must have a normal distribution. So you'd have to go through and test the normality. You'd go back, we've covered that before, how do you test normality? With a known standard deviation. Now in this case, the known one is going to be the known sample standard deviation. If you were doing this the traditional method of hypothesis testing, this is the formula right here that you would use for calculating your test statistic. I'll be using the p-value method as I go through these. And like I mentioned, we're going to substitute the sample standard deviations for the population standard deviations. Okay, so let's take a look at an example here. A consumer credit or education, organization claims that there is a difference between the mean credit card debts of males and those of the females. Notice it's not whether it's more or less, just that they're different. The results of a random survey of 200 each, so there's 200 males, 200 females, resulted in the following set of data. That was the average amount of debt by females, with a standard deviation of 750 and a sample size of 200. For males, there was the average debt, standard deviation, and in this case, it happened to be the same sample size. Okay, so we're going to go through and test this. To do this, you're going to be looking for a two-sample z-test. Z-tests, we're testing a mean, and it's big enough that we don't need to worry about doing a two-sample t-test. So, because it didn't say which thing would be less or more, we're going to do a two-tailed. You'll notice down here I've selected this for two-tailed. And so then I'm going to have that, notice how things get entered here. This is actually can be really easy to mess this up. You got to have the sample standard deviation here with that number there, they kind of jump around here a little bit. And that number right there. Okay, so we've got the first group's sample standard deviation, their mean, and their size. Then we got the second group's sample standard deviation, and then we're going to have its mean and its size, the sample size. Again, this is going to be two-tailed, so we go ahead and we run it through, and there's our p-value, 0.3, which is greater than 0.05, so we're going to fail to reject on this one. But that's how you do a two-sample test of means when you know the standard deviations, and they are large enough that we don't have to use the t-test. We'll get to those at another day. So our conclusion, at a 5% significance level, we fail to reject the null. Therefore, there is not enough evidence to support the claim that there is a difference between men and the mean credit card balance of men and women. All right, let's take a look at another one here. Safety engineer records the braking distance of two types of tires. We have two different kinds of tires here. They randomly select samples of 35 tires. The results of the tests are as the following. Type A here, their mean stopping distance was 42 feet with a sample standard deviation of 4.7 feet. Here, with this one, the mean stopping distance was 45 with a sample standard deviation of 4.3. At a alpha equals 10%, 0.10, is there enough evidence to support the claim that a tire A has a shorter braking distance than B? Okay, so this was 42, that's 45. So in this case, we're going to have the null be greater than or equal to, and we're going to have the alternative be that this one's less than this one. You do need to be careful when you're putting these things in, paying attention to then which one's less than. So the last one had an equal. Since this one's less than, you're going to have to be careful about this because we're choosing that this is less. So watch which one you're calling your first and which ones you're calling your second. So this will be my first. First is less than second. Now, I can, of course, go ahead and choose this, but then I would have to flip-flop these numbers. So you got to pay attention to that. Which tail are you going to use, and then which set of numbers need to go where to get that inequality pointing the right direction. As before, though, you put in the sample standard deviations, you put in the means, you put in the sample sizes, and then, of course, we can just run the test. And in this case, our p-value is 0.00. Just call it 0.003. Either way, it's less. Okay, so since the p-value is so low, we can reject the null and we can accept the alternative. So our conclusion is that at a 10% significance level, there is enough evidence to support the claim. This one was the claim, by the way, that tire A has a shorter braking distance than tire B. The main takeaway for this example versus the last one, though, was you've really got to be careful of this and which one you're calling your first, which one you're calling your second, because, of course, that's going to make a difference. You could mess it up easily if you're not careful for that. So why don't you guys give one a try? And remember, this one's going to be, I believe this one, I suppose I should read. Yes, this one's going to be a less than situation, so you're going to want to pay attention to which one's first, which one's second. The American Automobile Association claims that the average daily cost for meals and lodging in Texas is less than the same average cost for vacationing in Virginia. So I think it meant actually the same amount of time. So they're saying that Texas is cheaper than Virginia is less than. There's some data there. Why don't you go ahead and run a hypothesis test, give it a try. All right, so again, you got to keep track of what's the first thing and what's the second. So our first one, that's going to be Texas. So we got to use the Texas numbers here, here, and I lost track of where it was here. Here we go. And then the Virginia numbers are going to be here and here and here. Less than, again, is what we're looking at here. And I'm assuming you came up with this, a p-value of 0.17. So in this case, we are going to fail to reject the null. So there's not enough evidence to support the claim that the average daily cost for meals and lodging for vacationers in Texas is less than that for vacationers in Virginia. All right, if you want to do a little more practice, there are 2 more questions in Schoology. Have a good day.